So welcome back, everyone. Now we're gonna continue to the second part of today's workshop, where we are going to discuss some techniques of data analysis. I'll be presenting on some quantitative approaches, and Jay Hodson will be presenting on qualitative approaches. So I'm Felipe Soares. I am a postdoctoral fellow at the Social Media Lab at Toronto Metropolitan University, where I work in the area of computational social science. And in the agenda for today, I'll start talking about how we can use some computational social science resources to analyze antisocial behavior online. Then continue, I will talking about how to do toxicity analysis using perspective. And finally, I'll show you how we can use social network analysis with side networks to study and understand antisocial behavior on social media. There are many ways to study antisocial behavior online. From my presentation today, I will introduce you to a few computational social science tools and approaches to explore questions such as what is the prevalence of toxic interactions in a given data set? Who are the main targets of toxic messages? And who are the main perpetrators of this toxicity online? To answer these questions, we can combine machine learning and social network analysis. And today I'll show you how to do it by using Perspective API and signed networks. Computational social science is a field that studies social behavior through the use of computers and computational tools. As computational social scientists, we can use techniques such as machine learning, social network analysis, sentiment analysis, toxicity analysis, topic modeling, and many others to make sense of digital trace data. So as I mentioned, I'll start talking about one of these techniques, Google's Perspective API, which is one of these computational tools. Perspective is a free tool created to help people host better conversations online. Perspective uses machine learning models to score the perceived impact a comment might have on a conversation. So Perspective was trained to recognize a variety of attributes, whether a comment is toxic, threatening, insulting, and so on. And it was trained using millions of examples gathered from several online platforms and reviewed by human annotators. Perspective uses machine learning to analyze the text and to determine its level of toxicity. So it gives you a probability score with values between 0 and 1. A higher score indicates a greater likelihood that a reader would perceive the comment as containing the given attribute, such as toxicity. So the closer to 1, the more likely a message is toxic. Instead of a binary classification, the range between 0 and 1 allows researchers to validate perspective scores and also select the most appropriate threshold when analyzing data to identify which is considered toxic. Okay. I'll go over the details of each attribute in the next slide. But first, let's look at this example. The message here is, "Shut up, you're an idiot!" exclamation mark. We can see that the probability score for toxicity is 0.99, so very close to 1. So most people would likely consider this message toxic. That's similar for other attributes such as insult and profanity. While here we are looking at only one example that we could easily classify as toxic, Perspective is super useful when we have a large data set and we want to discover which messages in this data set are likely toxic. Perspective provides scores for 16 different attributes, but some of these attributes are still experimental. Out of the 16, there are 6 attributes that are considered prediction ready, meaning that they have been tested across multiple domains and trained on significant amounts of human annotated comments. So these are the attributes that Google deemed reliable and recommend using. These different attributes are just basically different manifestation of antisocial behavior. So let's start with toxicity. That represents the degree to which the comment is rude, disrespectful, or unreasonable. Severe toxicity looks at how hateful, aggressive, and disrespectful a comment is. Insult helps us to identify insulting and inflammatory posts. Identity attack indicates if a post contains hateful language targeting someone because of their identity, basically because of who they are as a person. Profanity indicates if swear words or other profane language are used in the text. And finally, threat represents the degree to which a post displays an intention to inflict pain or violence against an individual or a group. There are different ways to access perspective to run a toxicity analysis, including Python scripts, for example. But as Anatoly mentioned earlier today, there is also an easier way that doesn't require any coding skills to access it and to run a toxicity analysis. So today, to demonstrate how we can do it, I'll use Communalytic as a case study to illustrate how we can use perspective to analyze large data sets. I first used Communalytic to collect a data set from Twitter. You, of course, can also use a Communalytic to collect a data set, or you can just simply import your own data set to the tool and then run the analysis. On Twitter, as you probably know, people use hashtags to associate their message with a particular topic. If you are a researcher, you can focus on one of these hashtags to understand how users are engaging in a conversation on social media. Or, as it is the case with our analysis, how they're being toxic on Twitter. So for demonstration today, I'll focus on a hashtag criticizing Justin Trudeau, the Canadian Prime Minister. I collected this data set for this workshop, and the idea is simply to illustrate how we can use a toxicity score to explore social media data. You can use any other data sets according to your own research interests. So for this demonstration, I collected over 30,000 tweets posted in July using the hashtag Trudeau must go. We know that these messages are likely criticizing the Prime Minister, but as researchers, we want to know more. For example, how can we identify which or how many tweets are toxic in this dataset? In the old days, you would probably need 2 or 3 coders to manually label every single one of these 32,000 tweets. That would be a lot of work, and it would take a lot of time. But using perspective can expedite this process. So after we ran the toxicity analysis using perspective to discover the probability scores for different attributes in our dataset, we can look at their averages. And the attribute that we will focus today is toxicity, because it's the most broad one and also the most well-validated score by Google. Just as a reminder, toxicity is defined by perspective as rude, disrespectful, or unreasonable posts. We can see here that the average for the dataset is 0.2. This indicates that out of the over 30,000 tweets, only a few messages were likely toxic because the average is quite low. But we can also see that some messages in our dataset have high scores for toxicity, very close to 1. So let's look at some examples. As you can see, the score provided by Perspective for these 3 messages from our dataset is 0.99. So it indicates that these messages are very likely to be toxic. These messages, these examples, are targeting Justin Trudeau and include some offensive terms, using a lot of the F word, for example. Perspective gives us probability scores for each message, every single message in our dataset. So we can use this score to compare different tweets in our dataset. And then we can use it to identify which messages are likely toxic or not. We can also look at the distribution of the toxicity score in the dataset. As the chart is more dense on the left side, closer to 0, we know that most messages in our dataset are likely not toxic. When you analyze your own dataset, this is the distribution you would expect from most datasets, except if you use a search query that includes swear words, or if you are analyzing a very specific conversation that is very toxic. But in general, the distribution for most social media conversations will look more or less like this. But what's most interesting to our analysis here are the messages on the right end of the chart, those with the highest toxicity score. Because these messages are the ones with the highest toxicity scores, these are the most likely toxic messages in our dataset. So another way to analyze toxicity in a dataset is by setting one specific threshold to identify likely toxic messages, and then counting the percentage of messages above this given threshold. We can choose different thresholds to what we consider toxic. Lower thresholds will capture more toxic messages, but might also include some false positives, so messages that are actually not toxic. While higher thresholds will reduce the number of false positives, but might also miss some toxic messages. So let's first look at 0.7. If we use 0.7 as a threshold, and once again, score gives you a perspective gives you a score between 0 and 1. So 0.7, we have 1,433 messages from our dataset would be considered likely toxic, which represents 4.4% of the messages from the dataset. If we use 0.8 as a threshold, this number would decrease to only 472 messages, or 1.4%. You can see, as I mentioned, that the higher the threshold, the lower the number of messages. So selecting the ideal threshold depends on the research objectives. If you want to have a larger pool with some potential false positives, or a more restrictive pool of messages. A good way to select the best threshold is based on a sample of your dataset coded by human annotators, so you can identify what threshold works best for your dataset. And now, switching gears a little bit, I'll show you another way to analyze this dataset by using social network analysis with signed networks. But before I tell you more about signed networks, I'll give you a quick primer on social network analysis. To build a signed network, we have to first start with a communication network. To do that, let's go back to our sample dataset, #Trudeau must go. Here, we have a tweet posted by the Canadian Prime Minister, Justin Trudeau. And another user, Twitter user, replied to his tweet. As researchers, we can transform this type of interaction into a network. So let me show you how. In a network, we have two very important elements, nodes and edges. In our case, nodes are social media users, Twitter accounts. And edges represent interactions between them, between these users. These communication networks can represent different types of interactions, such as retweets, friendship, who follows whom, and so on. Today, we will explore a network of replies. So connections between nodes represent that one user replied to another user. So here we have two different users replying to Justin Trudeau's tweet. As researchers studying antisocial behavior online, we can add another layer of information to this network. We can go back to perspective toxicity scores to discover if these replies were toxic or not. So this way, we can actually create signed networks by assigning a positive or negative weight to ties depending on the toxicity score of the reply. Now we can see that when user 1 replied to Trudeau, the message was toxic. But when user 2 replied to Trudeau, the message was not toxic. By adding perspective toxicity score to our network, we create then an additional dimension to our analysis. So on top of identifying active or influential users in a network, we can also see who is being nasty in the conversation and who are the targets of these toxic messages. So let's go back to that exchange again. When we read this reply, we can clearly see that it's toxic. So now let's look at perspective's toxicity score. As expected, perspective gives us a score of over 0.98. Because the score is very close to 1, we can consider that this message is very likely to be toxic. So when building the network, we can assign a negative weight to this edge because the message is very likely toxic. To decide which interactions will be considered toxic in our network, we can again select a threshold. For the demonstration today, we will use a 0.7 threshold to identify likely toxic messages. So this is the network representation of the hashtag Trudeau must go dataset. So I took all those 32,000 interactions and looked among those who replied to whom and transformed it into a network. Each node here represents a Twitter account, and each edge between them represent a reply. So one user replying to another one. We can explore this network and this data set in many ways. We can see users' interactions, most and least active users in the conversation, identify influential users or users that are more likely to be influenced, and so on. But now that we have access to the toxicity score, we can also identify where are the toxic interactions. So we can transform this communication network into a signed network, where edges have different weights depending on how likely a toxic a message is. So once we add toxicity scores to each of the interactions in the network, we can see which of these interactions are toxic. Now, those toxic interactions are highlighted in red. To make it easier for us to visualize, here is a zoomed-in network only containing the toxic replies. So first, we can use the toxicity scores and sign networks to identify the targets of toxic messages. In this conversation, we can see that Justin Trudeau is on the receiving end of a lot of toxic message. This is why the node in the representation is the biggest one in the visualization for Trudeau. So by using these two methods, combining perspective scores and social network analysis, we are able to answer a lot more nuanced and interesting questions about this conversation. So now let's look at a couple of examples of toxic tweets targeting Justin Trudeau, the Canadian Prime Minister. This first example is telling him to go to hell and calling him a liar. And this other interaction is asking him to resign and get the F out of Canada. So these are just to illustrate the analysis, but by using these approaches, we could assign toxicity scores for the messages in your data set and then use this sign network to identify the main targets of toxic messages in our data set. We can use the same method to look at who is being nasty in the conversation. So now, bigger nodes are users sending more toxic replies. So once again, by combining toxicity analysis and sign networks, we can also identify the perpetrators of antisocial behavior online. Let's again look at a few examples and what they are saying. This user is targeting left-leaning Canadian parties, such as the NDP and Liberals, calling them stupid and morons. This other user was targeting Justin Trudeau, but also targeted the former Green Party leader, Elizabeth May. So these methods helped us to identify users that often posted toxic messages in our dataset. Imagine, once again, going through all the 32,000 tweets that we collected and then coding one by one to identify whether the message was toxic, who sent it, and who was the target of that toxicity. By using perspective and creating signed networks, we can make this process faster, simpler, and on top of that, also create a visualization that helps us to explore and communicate the results of the analysis. So just to summarize the approach I presented today, we start, of course, by collecting a data set from social media. Then we use perspective to discover toxicity probability scores for the messages in the dataset. From there, there are different approaches you can use to explore this data. We used perspective toxicity scores to add another layer of information to our network from Twitter. So we use perspective scores to identify toxic interactions in a signed network of replies. By combining these two methods, we were able to easily identify the main targets and the main perpetrators of toxicity in the conversation. So just to conclude, we can quickly discuss some main pros and cons of the approach I presented today. In terms of pros, these techniques allow researchers to analyze and summarize the results of large datasets. We can use perspective to analyze thousands of messages and create signed networks of toxic interactions. While in the old days, we would have spent a lot of money and time coding these messages and often depend on research assistants, etc., to code these messages, perspective makes the process simpler. These techniques can also be easily validated by other researchers. We can manually also verify a sample of the messages to validate the probability scores given by perspective and select the most adequate threshold for our analysis. Other researchers can also run similar analysis to validate our results or simply to reproduce our method. But of course, this approach also has limitations. Perspective and other machine learning models likely won't be able to identify overt toxicity. So if toxicity is implicit in a message, or the message contains a term that is only toxic in one very specific context, it is likely that perspective won't be able to identify it as toxic. And that's because perspective is not able to detect patterns of toxicity that it has not seen before. So in addition to that, perspective might also incorrectly detect toxicity in a health comments that contain similar patterns to previous conversations used to train that machine learning model. So it basically reproduces what was input into the model. When you use perspective to analyze a data set, you are also limited to the categories provided by Google. So you won't be able to look at more nuanced categories, such as different framings in messages from a data set or any other category that was not built into perspective. To address some of these limitations when studying antisocial behavior online, we can use mixed method approaches, combining these quantitative techniques with more qualitative techniques, as some of which Jay Gris will talk about soon. But before that, we have a few minutes for questions. So if anyone in the audience in person or via Zoom has any questions about these quantitative approaches, I'll be happy to answer them now. Thank you.
All right, we have a question online from Stu Schulman. Stu says, why would a researcher want to let Google or any other entity create their categories? And I'd love to tack on to that, Stu, and because I had the question of, is there any way to influence then perspective to develop other categories? So let's begin with Stu's question. I guess, what are some of the challenges even of having those categories pre-made? What can we do about it?
Yeah, great question. There are other machine learning models that also try to do similar analysis. We've been testing a few of them. We've been trying to also develop new ways to analyze these data sets. Of course, it is a limitation. I even mentioned in the previous slide that we depend on Google to use the perspective. But Google is also quite open to some extent in terms of adding new categories. They've been working with some newspapers and news outlets such as the New York Times to create categories that are specifically focus on comments for their online web pages, where you probably know comments in news online are very nasty. So perspective is open to some extent in creating new categories. They also are open to some extent in receiving feedback from researchers. So if you identify some issues with these models, some unintended biases, you can tell them. But of course, just to that extent, because then we depend on them to actually change it or to improve it based on researchers' feedback. But there are several initiatives to create similar models and machine learning models to do similar analysis. So yeah, hopefully in the next few years, we're going to have also researchers being able to create their own models in a more academic way that we have more transparency and we can actually have more chances also to discuss them, to validate them, and to provide feedback.
And we have a follow-up question from Stu and Dina, actually. So Stu says, do you treat accounts that tweet once per day the same as those that tweet 100 times per day? And then Dina was also wondering about how the edge weights are calculated in the network.
Good questions. So for this particular analysis, we treated then accounts tweeting 1 or 100 times per day equally, because we didn't want to identify bots, for example, and this was just to illustrate the method. So it wasn't like a very in-depth analysis to discover something we couldn't know before. It was just to demonstrate how we can use these techniques to better understand the data set. If we are doing then a research project that we want to know who are these trolls, who are these nasty people online, definitely we would probably look at how often they comment, how different they interact with other users online. In terms of the edges, Dina's question, for the basic edges in the communication network, we're gonna look at the reply. So if they reply to the same user 2-3 times, the weight will be based on how often they reply to another user. But we use the toxicity score, so the probability scores between 0 and 1, to create the sign network. So you can use different attributes to weight the edges. Of course, for the communication network, it would be replies. For sign networks, you can test toxicity, insulting, threatening, etc., etc. So you can use both attributes or both metrics to better understand these conversations.
Great. And Ying Ying Chen asks, the process for determining 0.7 as the toxicity threshold and any validation recommended to determine the best threshold number, because you noted the difference between 0.7 and 0.8. So what's your recommendation for how to determine that?
Yeah, so Perspective itself has a few tests to understand what are the best thresholds. So in general, they don't recommend using 0.5, for example, because it's a probability score. So 0.5 means that it's kind of like you flip a coin and then it would decide whether it's toxic or not. So ideally, it would be at least 0.6, 0.7. In some of our research, or in some of our studies, we identified that likely 0.7 and 0.8 are usually the best thresholds. But the best way, as I mentioned, is for the researchers to explore the data set, go read the messages after they have the scores, so they can actually validate and identify, okay, it's in fact messages like above 0.7, most of them are likely toxic. There are some statistical ways to do that kind of analysis. You can use content analysis, having a few coders to analyze a sample of the data set, then compare the number of true positives and false positives to identify the best threshold. But usually it will probably be either 0.7, 0.75, 0.8 in that area, because according to Perspective, when it's 0.7, 7 out of 10 people would likely consider that toxic. So it kind of gives us some idea of where to go from there. Okay, I guess we are done in terms of time. So I'd like to invite J. Grace Hodson to join us and talk more about qualitative approaches. Thank you.